Hello and welcome to Waka Waka breaking it down for you. I'm going to try to go through some of the answer key problems and kind of break down the reasoning and thinking behind some of the questions. Um, Things you should look out for, and then also common mistakes people make to avoid. So there's a little Waka Waka breaking it down. But this is the rational function and expressions where you're just adding and subtracting rationals. There's a different lesson on multiplying and dividing, and then there's a different lesson that comes with graphing. But this is adding and subtracting. So when you look at this this is the answer key. I'm just going to go through and go through the main points. So the first thing I'm looking for with fractions is a common denominator. So I'm looking at the bottom. These are just some simple ones to warm me up, but the idea will carry through when we have x values in the expression. So here we have a common denominator of 5. I don't need to do any extra work. We just add them together. 2/5 and 4/5 makes 6/5, right? We just add how many fifths we have. Common mistake people make is they add the bottoms and get 10 on the bottom. That works for multiplication. That's what you're supposed to do for multiplication, but it does not work for addition. Addition, you're just saying how many fifths plus how many fifths. So that's total of 6/5. Okay, so that's one idea you need to carry forward as we go on to the harder ones. Now this next one, part B, you can see that we do not have common denominator. We have a 10 and a 5, so I have to make those common. So this is 3/10, so I'm just going to leave that the way it is. And I'm going to change the 5 into a 10 by multiplying by 2. If you multiply the bottom by 2, that means you have to multiply the top by 2 as well to keep it even. So 2 over 2 is just 1, right? So it's kind of like multiplying by 1. You're not really changing the value of it, you're just changing the form of it so you can combine it. So when I multiply by 2 over 2, you can see the 4 times 2 gives me my 8 over here, and then the 2 times 5 gives me 10. So now I have a common denominator. But before I move on, I want to just point out 8/10, what I end up with there, is the same thing as 4/5. It's just kind of a different form, right? We could take 8/10 and simplify it back down to 4/5, and it would be the exact same value, right? If you change it to a decimal, they would both be 0.8. So there's no change in value. It's just changing the form so that we can put it together. So now I have a common denominator. I can add the tops to get 11, and then the bottom does not add, and you get 10. It just stays with 10. 3/10 and 8/10 make a total of 11/10, right? Okay, next one's the same thing. Even if it's subtraction, still the same thing, but you're going to subtract the tops. 9 minus 1, 8. And then, of course, you try to simplify things afterwards. 8 over 16 is a half. And then this one, I need a common denominator. So I'm thinking, what's common between 7 and 6? Well, that's going to be a greatest common factor of 42. Well, it should be least common multiple, right, is what we're looking at. Okay, so then I multiply the left one by 6 over 6, the right one by 7 over 7. So again, same thing as before. It's not changing the value, just changing the form. And you see I get the common denominator of 42. That's the goal, right? Get a common denominator first. Then you can put things together. 18 minus 35 is a negative 17, and you're done. Please pause and go back over it or whatever if you need to. But this is just kind of laying out what you're going to do, but now with the rational expressions. You got to understand that first. If you don't, make sure you do before we move on. All right, so now when you have rational expressions, again, I'm looking for common denominator. That's the goal, right? Now, this is, of course, when you're adding or subtracting, adding or subtracting. If you're multiplying, dividing, you don't need to find a common denominator. These have a common denominator of x plus 5. So what do I need to do? Well, nothing, because they're already common. So I just have to add the tops. X plus 3 of this, whatever this is, plus 1 of those. So x plus 3 plus 1, right? This plus goes with the 1. So that's x plus 3 plus 1. Well, 3 plus 1 is 4. So that's just what you end up with. The bottom stays the same. Okay, same thing down here, except now I don't really see a common denominator. Don't make it overly complicated. Think about what's going to be the easiest way. Some people think that they have to multiply this by 2x plus 8, right, on top and on bottom. But that would be going overboard. There's too much work. All I have to do is multiply this one by 2 over 2, And it takes a little bit of insight to see that, but you have to see that what can I multiply this by to get this one over here? Well, you don't have to multiply by a whole big thing. You just have to multiply by 2, because that would end up being 2x plus 4. A different way of looking at it is, what if I factored this one first, which is actually a good thing to do on most of these. Just factor them first, and then it's easier to see what you need to do. Okay, so I'm going to factor this 2x plus 8 out, and you'll see I just took a 2 out from each of those terms. And if I distributed it back in, right, if I multiplied that back in, I would go right back to 2x plus 8. So I distribute those in, I get 2x plus 8. So this is a factored form. You can see now that this has the x plus 4 piece, but it doesn't have the 2 like this one does. Oh, so that kind of helps me see that I just have to multiply by 2 over there. Okay, so that's what we did here. We multiplied the top and bottom by 2 to end up with a common denominator of 2x plus 8. Once I have my common denominators, I just add the tops and the bottom stays the same. 7 of these plus 6 of those is 13 of those, right, total. And we just, again, the plus goes with the 6. So 7 plus 6, right? Okay, so they should go a little faster now. This is already has a common denominator. You just subtract. Just the common mistake I want to point out is that this 2x plus 5 has to go in parentheses when you subtract. That negative has to distribute into each one of these pieces. It can't just go into the 2 only. That's a very common mistake. People will say negative 2x, but they'll forget about changing the negative 5 to a positive 5. So make sure that you kind of think of this as a group, and you don't forget to distribute that negative in. So you can see here this changed to a positive 5 right here, right? And this was a negative 2x right there. Okay, so then you can put like terms together, right? We already did the common denominators, so that's done. That's already kind of under one fraction. That's always a nice thing to do. Just get it under one fraction first, and then you can start simplifying things down. Don't try to do too much at once. 3x minus 2x is just x, and then 8 plus 5, 13. Makes it way easier than trying to do it all from like here all the way to the end in one step. For many people, and even me, I don't like to do that. It's too much. I like to just put it under one fraction first and then simplify it out. Okay, we need a common denominator in this one. You can see that the x plus 6 and x plus 7 are not the same. Neither one of those factors. So there's no way to really there's no short way to do it. So I'm going to have to multiply this whole thing, this x minus 6 times x plus 7 over x plus 7. And I'm going to have to multiply this x plus 7 times x minus 6, x minus 6. Right? I'm trying to make a common denominator. And I know it looks really complicated, but if you go back to the easy ones, like the easier, it's still just the same process, right? I'm multiplying the right-hand one by whatever it was on the left, and I'm multiplying the left-hand one by whatever it was on the right. So that's going to give me, like in this case, I actually get a number, so it's easier for your brain to handle. But when you get down here, you just have to go with it. You just have to say, okay, this whole thing now becomes my common denominator. And even though I put the x plus 7 on the left here and the x minus 6 on the right, it doesn't matter. They're same thing, right? Because it's, right in between here is multiplication, right? So if it's multiplication in between there, it doesn't matter what order, right? These can be flipped back and forth. It doesn't matter. So these are the same. This and this are now the same. I have a common denominator. First thing, just put it together into one fraction. Don't forget this negative has to kind of go with this 5. And then so I could do this, like some people like to do this, change that to a plus and put the negative right here with the 5. And then it's a little easier to remember that you have to distribute that negative 5 into that. That's not a bad way of thinking of it. Or if there isn't a 5 there, you just make it a 1 and make it a negative 1 and distribute the negative. Okay, so I got to distribute that negative with the 5 though. So this side over here, right, becomes x squared and 7x, which you see here. And then this negative 5 will go into this, right? I got to go into here and here. So that's negative 5x there. And then I also have to do negative 5 times negative 6, which is your positive 30. Now you can simplify stuff. 7x minus 5x is 2x, right? And then you're simplified. Some people want to try to expand this afterwards and go further with it. That's just a waste of time. We actually like factored form. If I was trying to graph this or something, I would be able to see what makes the bottom 0 really easily. So I just want to leave it like that. And in fact, I do want to go one step further, and I have to ask myself, does the top factor? So I don't really want to expand anything. I actually want to try to take the top and see if I can factor that out. Sometimes things will cancel even at, like after you put things together, something will cancel off. So I got to check that out. I got to say, okay, let's see here. 30. What are the factors of 30? 1 and 30, 2 and 2 and 15, 3 and 10. What else I got? 5 and 6. So I got to go through all the factors of 30 and try to find some combination that's going to give me a positive 2. And if I look at all those combos, there's nothing. There's nothing that's going to give me 2. So this one does not factor. If it doesn't factor, then you're done. Just leave it the way it is, and we'll know that it's already been factored. Okay, I won't bog it down anymore. That's really the main goal on how to do those things. There is a worksheet that goes with these. If you look in the unit plan right here, there's an extra practice one. The answers are at the end of it. That's a great place to get in there and just try some extra problems that are more like these, right? Or sorry, more like all these, right? With addition and subtraction. Okay, you need to practice. It's like anything in the world. If you don't practice, you won't get better and you'll just forget. It's like me learning Japanese or something. Okay, so these are the word problems. And again, we're trying to introduce why in the real world would you ever run into something like this, having a fraction? Why am I doing math, Mr. Waka? Well, you're doing math to get more logical and to be a critical thinker, but you're also doing math so that you can see how certain things work in the world, right? I don't care what kind of job you're going to do in the future, you're going to need some math, especially to the algebra 2 level. Anyway, so this one you can see that we have s plus 30 on the bottom and s minus 30 on the bottom on this one. I have a variable on the bottom. But what's going on? Okay, so we've got an airplane that's flying that's 678 miles. The wind speed is 30, right? So when you're going one direction, the wind is pushing you, so you get s plus 30. And when you're going the other direction, you're coming back, the wind is going against you, so you get s minus 30, right? So those are kind of going against each other. That's why it's s plus s minus. Now, why are we dividing? Well, 678 is miles, right? That's how many miles I'm traveling. And the s plus 30 is a speed. And it's just a formula, like speed equals, like, it's usually like miles per hour or whatever. This is in hours, right? So it's the wind, and your flight speed s is in miles per hour. So if I divide miles, which is the 678, divided by miles per hour, which is the speed, right? I don't know if you remember, but like we did this earlier, when you divide, the previous lesson we did this, if you divide something, that's the same thing as multiplying by the reciprocal. So instead of dividing by a fraction, this miles per hour, I'm going to multiply by the reciprocal. And I'm just doing it in units right now, so you can see what's going on. I'm not talking about the numbers, right? Not yet. So you can see here that the miles will cancel and you'll be left with hours. So when I take, sorry, I don't want that. When I take this 678, which is a distance, and you divide by the speed, right? So any kind of distance divided by speed will give you time. And there's I think most people know that, right? If you take your speed and you multiply by distance, you'll get time. There's physics kind of uses that formula, right? So it's the same thing, but I've divided by the speed. So I've taken my distance, or my distance. I think I had that backwards. My distance divided by my speed, and you will get time. Okay. So, I think I had that formula wrong. Sorry. So ignore what I just said, but the same idea, right? So that's what they're doing. They're just trying to figure out. So F is the time. It's the time in hours. So they're asking, what does F represent, right? Well, this is the flight time going one way with the wind behind you. And then G is the flight time going back with the wind against you. Okay, so that's why I have S plus and S minus. All right, and it describes it there. Okay, when I add those together, what's that giving you? Well, this is the time it took to go one way. This is the time it took to go the other way. So if you add those together, you're going to say the time going one way plus the time coming back. That's like a round trip, right? So that's the round trip from Chicago to Philadelphia and back. So let's define that with a new function. So that's what we did here. We said, let's make that a new function. Let's make R for round trip, right? So maybe F is for going there, like for, I don't know, first or something, right? And then G is like going back. I don't know. We're just using F and G. But let's say R is for round trip, okay? So you can see we added those together. We're noticing these are not the same. This is one's a plus, one's a minus. So they're not the same. So we have to find common denominator, just like we did before. Multiply the top and bottom. Don't forget to distribute when you're trying to simplify stuff. Okay, you put it all together. After you distribute, you try to simplify it. You'll notice the 6/78 will add to give you that. But you'll notice these two 20,000s. One is positive, one's minus. They're going to cancel and simplify. So all that over one common denominator. Remember, we don't add the denominators. And that's it. That's a simplified version. There's nothing else you can do with that. You can't cancel S's or something like that. Some people try to do that. This is multiplication on top, but on the bottom you have this subtraction and you have addition there. You can't cancel a piece of that. They kind of go together as a group, right? That's really important. That goes for like when you're back up here, right? Some people try to do things like, let me cancel this X with this X. It's like, no, you can't do that because there's subtraction right in between. So you can't do that, right? Okay. So now that we have our formula for the round trip, they're saying, let's find this. Now you need to know your function notation from unit 1, right? Unit 1 says this value is the value you input into your equation. So, okay, so what's that mean? You're inputting into S then, basically, right? Because this is R of S. So S is the variable. And in this case, S was the wind speed, or no, not the wind speed. The 30 is the wind speed. S is the speed of the plane, right? So how fast you're traveling just by the plane alone. Okay, so you divide those, or sorry, you input that in, and you end up with 4.42 hours. So what does that equal? How do we know this is hours, in other words? Well, that's because we said that R was the time that it took to go round trip. It's the time to go round trip. The 310 is the speed of the plane, and that goes along with the wind speed going there and back to give you a total round trip of 4.4 hours, right? And there you go. That's a nice word problem. The rest of this is just practice. So there's a little practice here you can do, adding things together, making common denominators. You need to know how to factor things first before you can look for common denominators. This is a difference of square that you need to kind of work with. Make sure you don't forget about those from Unit 2. Don't forget how to factor different things from Unit 2. That's all stuff you're going to practice while you're going through Unit 3 stuff. Okay, so take a good look at those. And of course, always come in for questions. I'm here to help. I have plenty of time free during my free blocks and during lunch or during community time. Okay, so make use of that if there's something here you don't understand or the video. Good luck.